Hi. Let me move the screen to full screen. Zoom. No. Okay. Yeah. Hi. This is Param. Uh, of course, right now in this playlist we are seeing like what is the aggregations, what are the different type of aggregations are available. Okay. So of course, purpose of them also I have explained in my previous video. Okay. So in this video, I will like in the last video we have seen sibling based pipeline aggregation. That means aggregations are there. Okay, it could be metric most of the times. Okay, okay. So okay. So from that metric from the sibling aggregations, the aggregated values pushed into the pushed into or as a given into the sibling aggregation. So it have done it has done some its own work. Okay, so I think explained all the what min maxims everything I have explained in the previous videos. Now we will see parent level aggregation. Of course, the count is more, I believe. Okay, count is more than sibling basis aggregations. So since this is also pipeline aggregations, obviously it will get the input from the other aggregation, not from the document itself. Okay, okay, fine, yeah. So there is no grouping happen. So that's why pipeline aggregation never start with UGs. Okay, it never start with the UGs. Okay, I think I have explained that also in earlier. I will show the demo also. Okay, but I will explain now. I'll start. Okay. Theoretically, I will cover this stuff. Then I will show the demo in my Postman collections. Okay. So this is a bucket chart. So bucket chart means what? It will collect the it's sorting the let's say we have the 10 buckets. Okay. So we want to sort them based on the key, most of the time key, right, key. Okay, or count, how many number of document count is there. Okay, or size. Okay, from and size will tell the pagination, in fact. Okay, so you want to start 5th to 7th, or that's count. Okay, that is what from size. And okay, let's say I have 10 aggregate 10 packet aggregation in my things. So I want to start only 5th to 8th, only 3, or 5th to 9th. Okay, only these 4 aggregation I have to start. So in that case I can use the from and the size. Okay, size will say 4, from will say 5. Okay, so that's how. Of course, if you want to cut the aggregation also, you can say, let's say we have 10 aggregations, but you don't want you don't want to have you don't want to return to the all the 10 aggregation in the result. So in that case also you can cut the aggregation result using the from and the size. Let's say we have 10, right? As I said, if you want that only last 2 only thing, you can say like from can be 9, okay, and size can be 2. So obviously 9th and 10th aggregation will be aggregated packet only given to the user in the response. So that is what packet aggregations. Okay, okay, then normalize. I'll tell you the normalize what is. It has a set of predefined normalized functions are there. Yes. Okay, I have put these are the functions, rescale. Okay, it's kind of normalizing, normalizing what is a kind of calculating percentage or the percentage something. Okay, that's what that's similar to stuff, nothing else. Okay, yes, let's say instead of saying very big number, we can say if we convert it to the percentage, we can say 10%, 20%, 30% instead of saying actual figure. Similar way, nothing else. Okay, similar way our aggregate values has aggregate value has some numbers or figures. Okay, but if you want to scale them or normalize them, okay, so that is where you can use. It's kind of it will be useful for machine learning. Okay, it will be useful for machine learning. Okay, so these are functions: rescale 1 to 100, rescale 0 to 1, percentage of sum, mean, z score, soft, max. Many functions are there. Okay, in fact I have explored rescale percentage of sum, in fact. Okay, or in rescale 0 to 1, rescale 0 to 100. So that's how. Okay, you are reducing, you are changing the figure, that's it, to accommodate some place, that's why I said it's used for machine learning algorithms. Okay, so that is what normalize. Okay, then bucket script. Okay, bucket script, I thought I can write some any script. Okay, I can do manipulate, but unfortunately no. Okay, so using the bucket script, it will accept the numerical value only. Okay, so obviously what is it, the input must be must be what, metric aggregations, okay, input metric aggregations, okay. So it result also is returning the numerical value, okay. So that is what bucket script. So if you want to manipulate something, you can do that is what bucket script, okay. Inference what is, so you have the metric data. Yes, sorry, sorry, you have the bucket, array of buckets, okay. You have the array of buckets. Now you want to pass those value to the trained model, okay, trained model. And if you want to calculate some features, everything stuff, okay, instead of giving a raw value, instead of giving as a raw document, okay, usually what will happen, so see in the machine learning what we will do now, we will give us raw data. Sometimes we do transformation, I agree, as a data feed, okay, or pivot transformation, something like that, okay. Yes, pivot transformations, okay. We do some transformation and give to the machine learning. Outside we can use raw data as well, okay. Similarly, in the prediction and all, we will give raw data only, okay. Similarly, aggregated data, if you have aggregate data, but for that also you can apply your model. Wow, what a great feature, na? You have aggregated data, for that also you can apply the models, you can apply the machine learning, okay. I think I can consider, right. So obviously in my use case I will have aggregated data, okay. I can use those aggregated data for anomaly detections, right. Yes, so let me change the color. It will be useful for my use case. Green, not greens. Yellow, okay, not bad. Yellow, okay. So obviously in my I have use case, okay. So I will in my actual use case. So I will create the metric. Yeah, I will create the metric. No, count. I am using count. Okay, I am using count. So for that also I want to do anomaly detection. So then I can pass my aggregated packet to the anomaly detections, right. It's really good. Okay, then cumulative sum, cumulative cardinality. I will tell you what is cumulative cardinality. Say cumulative cardinality, what you will say now, how many new elements or new entries are there in each bucket. See from top to bottom, let's say again we have 10 buckets, okay. In the 10 buckets we come from first to 10, okay. In let's say we have year data, okay, we can have the year data. In the year data we want to identify for each month, okay, how many new users or how many new customers has comes, okay. If you want that, then you have to go for cumulative cardinality. So you have to aggregate your data based on the month, okay. Now if you apply the cumulative cardinality, then you can understand how many new customer has come on every month, okay. That is a sum, that is what cumulative cardinality. Then cumulative sum, okay. Cumulative sums, it's again what is there is a difference between sum and cumulative sums, okay. That there is difference between sum and cumulative sums. So sum, it will say what is the total values, okay, total value of sums. So for that we can use sum bucket. It's a sum bucket, that is what sibling based aggregations, sibling based pipeline aggregations, okay. But cumulative sum is different. So again we have 10 buckets, okay. So it is sum first on second, then give 10, then third bucket will have 1 2 3 third, then fourth bucket will have 1 2 3 4 5, something like that, okay. That is how cumulative sums will be populated. That is what cumulative sums. Derivative, okay, derivatives, okay. Derivative also work with mostly date histogram, okay, good. Then I can move this to here. So all of these things are working in the mostly in the histogram. Here whatever, okay, sorry, all these four works in the date or date histogram bucket only, nothing else, okay. Now bucket selector. Now bucket selector, you know, right, it's very simple. See, we have 10 buckets, right. I have 10 buckets. I don't want to return all the buckets based on some condition or based on the return value, something. Only those bucket I have to return. Let's say even okay, let's say minimum number, I want to have the bucket count more than 10, okay. I don't want to, or I want to have only less than 5, something like that, okay. I can selectively select the packet selectors. Okay, here we don't have anything. Okay, here we don't have anything in siblings. Okay, so if you want to selectively return the packets, then you can use the packet selectors. Okay, I think now I have explained. In this side of parent level of pipeline aggregations. Now I'll move to this side. Okay, this side I will say I am not good. I have tried the samples, but I didn't understand compulse. I didn't understand thoroughly. Okay, they will say moving function or moving percentile, serial difference, derivatives. In all of these four will work one thing: histogram, date histogram. Okay, here also this will work for histogram, date histogram. This also work histogram, date histogram. Okay, so all these four work only in the histogram or date histogram packet. Okay, that is one thing I can tell you. Okay, then all are working. See, first these three, first moving function, moving percentile, serial difference are working only in the time series data. Okay, then all three have they have a window. Okay, there's a window means what is an say, let's say we have that even in our machine learning metric viewer in the Kibana, we will be in the bottom you can select, okay, that what is the window you want to expand them. So that's how. Okay, so window, they are saying some window based on that they are doing some moving function, moving percentiles. Okay, so I am not understand thoroughly. Maybe if I get real use case, I may get thoroughly. Okay, so but I believe all these four are maybe useful in correlation or machine learning. That's what I can say right now. Okay. Okay, so that's why I put all these four in aside in separate columns. Okay, thank you, thanks for watching. So by this video, by these videos, we have completed that pipeline aggregation. So what are the pipeline aggregations? Okay, let's come on, escape, no, exit full screen. How to do? No. Okay. Yeah. Okay. So in this aggregations we have seen three type, right? Okay. So we have completed pipeline aggregations. All these are, so we can say like some set of pipelines are sibling pipelines. Set of pipelines are parent level pipelines. Okay. Okay, parent level pipelines. So these pipeline aggregations does not start. It is not embedded inside of the. It does not have own aggregation bracket, own aggregation block, adjacent block. It fit in the others. Okay, it fit in others. Okay, that is how it vary from these two. Okay, of course the input is an aggregated result, not pipeline aggregation. The purpose of pipeline aggregation, what is not, the input is the input is itself is not document, it's a buckets, aggregated buckets is given as a input. That's how it differ. Now I will show the demo. Okay, so in my collections I have put like what is it, I have put sibling based, parent level, then function based. So of course I have tried function based. I am not going to explain anything about that. Okay, now I will go parent. Okay, you can see that. Okay, packet selectors, here what I am doing. So that is what I am saying. See, this is a pipeline aggregation. It does not have own block. Okay, it sits alongside it. Okay, all the pipeline aggregations, all the pipeline, irrespective of sibling or parent packet. Okay. Okay, since it is a parent, what does mean? It is sit inside of the other aggregation. That's what, not sibling. Okay, that's a difference. So bucket selector. So here what I am saying. So sales amounts greater than 200, only that returns. Okay, that is what here. I think I can go by samples. Okay, so here, yeah, the count. Okay, packet count should be greater than 0. If it is not equal to 0, then only returns. Okay, so that means I am removing the empty packet. So if I have aggregations. Okay, I have aggregation. If I want to remove the empty aggregations, then this is the only way. I have to go for pipeline aggregations. So that's what, very similar. The straightforward answer is, whenever I want to manipulate the aggregated packets, if I want to manipulate any aggregated packets, then I have to check which pipeline packet will suitable for me. That's how, that is the use case. Then packet sort. Okay, here what I am doing, sort by dates. So you can see some syntax somewhat different, okay, but I am sorting total cells is total cells is the aggregations, okay. So I am sorting by descending order here, okay. So I want to return only three records, okay. Then truncate, yeah, that's what I said. If I want to truncate, I can use this one, size and from. Using these two, I can truncate the aggregation result. Again, it's a packet chart only. Cumulative sums, okay. Cumulative sums the same, okay. Cumulative sums based on the sales. Obviously, cumulative sums, cardinality, all are working in the numeric, okay. I don't know whether I have mentioned in my diagram or not, okay. Okay, cumulative sums numerical only, okay. This all works support numerical only. Cumulative sum works on numeric metric. This also work with the numeric metrics. Metric, okay. Okay. We were seeing that where is postman, yeah, okay, yeah, that's what, okay. Then cumulative cardinality, of course, you can understand that difference, okay. So what user is number, right, number, so it's distinct user on every day, or how I have, yeah, every day, so distinct user on every day, okay. Cumulative cardinality, normalize, I said instead of saying very big figure, we can normalize that using any function. So here with method I have used percentile of sum I have used, okay, on sales, okay. Bucket script, yes, you can do some custom scripting, okay. I believe it is a painless script, okay. So they have not said anything, so I think it is a painless script, okay. So here we can create a variable, you can see that I am creating two variables. Variables point to the aggregations, okay. Then I am applying the functions, okay. Then I am doing that. So here is that's our packet script. We can write some minimal scripting as minimal manipulations if you want something. Inference, of course, inference really interesting, okay. We can give that aggregated buckets as a input to machine learning model, okay. Machine learning models, okay. Yes, I think I have explained parent level, right? Yeah, parent level only. Okay, inference is not parent level, it is sibling levels, okay. I have to move to the sibling level. Yes. Pochapolia. Yeah, moved. Okay, that's all about the demo, okay. So of course moving function I have tried, but I didn't get that much understandings, okay. So nothing to spend time, it is not meaningful to spend time on that, okay. Okay, that's all about the pipeline aggregation. So the simple message by these two videos, what I can say now, if you want to manipulate your something on your aggregated packets, then pipeline aggregation is the only way, okay. So you can do many things. Some of the things are useful, some of the things are not. According to your use case, you can look which one is maybe suitable for your case, okay. That's all about the pipeline aggregations. Thanks for watching. If you like the content, subscribe my videos, subscribe my channels, like my videos, share it with friends, leave comments. Thanks for watching.